Hello everyone, myself Shwetnisha. So in the last video, we have covered section A of paper 1, 2024 Mathematics Optional Exam. And in this video, I'm going to cover section B. So in this video as well, I'm going to write solutions step by step so that it is useful for you. I'll break down every question in the easy steps. Also, I'll walk you through some of the key questions from the paper, especially specifically that question number 6A part, into what the UPSC expect you in terms of both technique and accuracy, right? So make sure you got your pen and notebook ready, right? So let's jump right into the details, into the solution. So section paper 1, section B. This is your question paper, section A, section B. We have already covered section A and we have to cover section B. You can notice in section B here that this E part right here was further divided into two parts, and C here was further divided into two parts. So this is your question number 5, A part. This is from ordinary differential equation. Find the orthogonal trajectory of the family of curve. It's written R is equals to C secant theta plus tan theta. And also note that this is in polar coordinates. So we have a proper procedure step by step to find the orthogonal trajectories. What do we do in polar coordinates? First of all, we find dr by d theta. So let's differentiate both sides with respect to theta. We'll get C secant theta tan theta plus secant square theta. So r theta will become C secant theta common, and this becomes secant theta plus tan theta. This r theta can be written as secant theta. And what is this C times secant theta plus tan theta? From equation 1, I can write this as r. So this is r secant theta. So the first step is to find the differential equation having this as its solution. Solution is this family of curve. So how we obtain a differential equation? This is in the formation of differential equation, and it is the very first topic in ODE. You eliminate all the arbitrary constants. So I have eliminated C, I got an equation. So this is a differential equation having solution as this curve. Okay, this is your first step. Next, in this differential equation, you replace dr by d theta minus r square d theta by dr to find the orthogonal trajectory. So to find orthogonal trajectories, let us replace dr by d theta by minus r square d theta by dr. Therefore, equation 1 becomes minus r square d theta by dr is equals to r secant theta. This r and r cancels. So d theta by dr is equals to minus secant theta divided by r. So it implies minus cos theta d theta. Separate the variables. 1 by r dr. Integrating both sides, we get sine theta is equals to log r plus, let's take that to be log a. Now the sine theta can be written as log of e raised to the power sine theta is equals to log r plus log a. And now you can cancel this log. This is e raised to the power sine theta is equals to r times a, where a is, here you can mention where a is, or log a is constant of integration. Constant of integration. And this is your required orthogonal trajectories. Okay. So it was a simple step. You just follow the steps and you will get the answer. Next, fifth B. Solve the integral equation, this using the Laplace transformation. So Laplace transformation is also in the syllabus of ordinary differential equation. Using Laplace, how we will do this question? You just need to know all the formulas of Laplace. If you know all the formulas, then you can do this question. So let's start. Solve the integral equation. So what is the first step? First step is apply Laplace both sides. So I'll get Laplace of y of t is equals to Laplace of cos t. Laplace transformation is linear in nature. That means it is distributive over plus and minus. So I have cos t plus this integration. So I can change it into plus Laplace of integration 0 to 1. 0 to t. This was 0 to t. Y of x cos of t minus x dx. Also note that this part should also remind you about convolution theorem. Convolution theorem is a very famous theorem in Laplace transformation. So the application of that was used here. So if I take that to be capital Y of S, then this is equals to what is Laplace of cos t? That is S by S square plus 1 plus, and this is Laplace transformation of this function, which is y of t, and this function in Laplace of cos of t. From here, and because you are using a theorem, a naming theorem, do mention it by convolution theorem. All right. Now, this Laplace of y of t, I have assumed to be capital Y of S. So that is S by S square plus 1 plus capital Y of S times S by S square plus 1. This is also capital Y of S. So find out capital Y of S as 1 minus S divided by S square plus 1 is equals to S divided by S square plus 1. So Y of S is equals to, let's first solve it over here, S square plus 1 minus S. I'm taking LCM. S square plus 1 is equals to S divided by S square plus 1. And now let's take this fraction on the right hand side. S divided by S square plus 1 multiply S square plus 1 divided by S square minus S plus 1. This gets cancelled. And now to find what was this capital Y of S? This is Laplace of Y of t. In order to find out Y of t, now you need to take Laplace inverse. To find out Laplace inverse of this expression in the right hand side, you need to make it a proper form. As you can see that there is a quadratic over here. So let's complete the square. By completing the square, how we do the completing of square? We take coefficient of this S here, which is minus 1. We divide by 2 and we take the whole square. So it's 1 by 4. So we add 1 by 4 and we subtract 1 by 4. Add 1 by 4, subtract 1 by 4. Combining first two terms and this fourth term, I'll get S minus 1 by 2 whole square. And combining the rest of these as constant, I'll get plus 3 by 4. So, Laplace of y of t is going to be S divided by S minus 1 by 2 whole square plus root 3 divided by 2 whole square. Just one last thing we can do before actually applying left line inverse both side is I can subtract half and add half so that it becomes s minus 1 by 2 divided by s minus 1 by 2 whole square plus root 3 by 2 square and plus 1 by 2 plus 1 by 2 divided by s minus 1 by 2 whole square plus root 3 minus 1 square. This is Laplace of y of. Now, how you will write Laplace inverse of this? Here, beta, when s is replaced by s minus half, you actually take t raised to the power at. This is a. You compare with the numerator by s minus a. So a is half. So it is e raised to the power half t. It's t by 2. Right? And then what is the Laplace inverse of s by s square plus root 3 by 2 whole square? That will be for cos. So it is cos root 3 by 2 times t. This is y of t. Plus, beta, here to take the Laplace inverse, I have to multiply and divide by root 3 also. So basically, this is 1 by root 3 and Laplace inverse of root 3 by 2 divided by s minus half square plus root 3 by 2 square. Now you can compare it with the Laplace of sine t, but because of this s minus half, you have to take e raised to power half t common here also. So your y of t becomes e raised to power t by 2 cos root 3 t by 2 plus 1 by root 3 e raised to the power t by 2 and it becomes sine root 3 by 2 t. And that is your answer. Next question, fifth C. It was from vector calculus. Vector analysis. Now, this question says at any time t, the coterminous edges means the edges which if you extend to make a parallelepiped, then it will enclose a volume. For example, x-axis, y-axis and z-axis. You can make a parallelepiped using them so that it encloses a volume. Okay, those kind of edges are called coterminous edges. Of variable parallelepiped are represented by this. So these are the edges given. The vectors along the edges are given alpha, beta, and gamma. What is the rate of change of vectorial area of the parallelogram? Okay, to do that, first of all, let me write that alpha, beta, gamma again. So alpha vector is ti cap plus t plus 1 j cap plus 2t plus 1 k cap. Beta vector is 2ti cap plus 3t minus 1 j cap plus t k cap. And gamma vector is I cap plus 3t j cap plus k cap. Right? 3t minus 1. Yeah, it was written, it was actually blurred. So I have written it once again. Now, first part of the question says, what is the rate of change of vectorial area of the parallelogram? So let's find area of parallelogram. Area of parallelogram. Now, as you can see that any two of the vectors can make a parallelogram here. So which area we need to find? You could have taken any area, any parallelogram basically. So that means you could have taken any two vectors from here. So let's find out alpha with gamma. So area of two parallelograms is given by alpha vector cross gamma vector. So that is going to be, this is cross product. Let's find out cross product. I cap, j cap, k cap. T plus 1, 2t plus 1, then 1, 3t, 1. Let's find out I cap t plus 1 minus 6t square minus 3t minus j cap t minus 2t minus 1. Then we have plus k cap 3t square minus t minus 1. Okay. Next, let's solve it. I cap, it becomes minus 6t square minus 2t plus 1 minus j cap minus t minus 1 plus k cap times 3t square minus t minus 1. Okay. Let us take that to be capital A. This is the area, capital A. So what does the question ask? Rate of change. How do we find rate of change? As you can see, it is in the only one variable, t. So it depends upon t. Rate of change with respect to, obviously, t is differentiate minus 12t minus 2 I cap plus j cap plus 6t minus 1 k cap. So where they are asking what is the rate of change of vectorial area of the parallelogram, whose coterminous edges are given. Okay, so it was given, right? I have taken alpha and gamma only. Also, find the rate of, so this part is over. This part is done. That is the answer. Fortunately, I have taken the same alpha and gamma. Also find the rate of change of volume of the parallelopipe. Beta, volume of a parallelopipe is given by the concept, which is again the first topic in vector analysis, which is triple product. Here, volume is given by scalar triple product. So first we find that volume and then we'll find the rate of change in it. For example, over here also we found first area and then we found rate of change of that area. So let's find volume. Now, volume V is alpha vector, beta vector, gamma vector. Okay, beta, this is the symbol that we use for scalar triple product. It will give you volume. Now to find the volume, I can also write it because you see this calculation that we have done, alpha cross gamma, I can make that calculation useful in the calculating volume also. So if I write it alpha cross beta dot gamma, you can do that. But that will be some extra calculations that you can totally avoid because this scalar triple product can also be written as gamma vector, alpha vector, beta vector. And this can be written as gamma vector cross alpha vector dot beta vector. And you have calculated alpha cross gamma as this. So what will be gamma cross alpha? Just change the sign. It is going to be 6t square plus 2t minus 1 I cap minus j cap t plus 1, or let me write it like this, t plus 1 j cap. I'm changing the sign everywhere here. Basically, I have multiplied by minus 1. So this is minus 3t square minus t minus 1 K cap. K cap. Dot B vector is this 2t I cap dot 2t I cap plus 3t minus j cap plus tk cap. 3t minus 1, yes. Now you have to do this dot product. So this becomes, let's multiply 12t cube plus 4t square minus 2t minus 3t square plus 3t minus t minus 1 plus this minus 3t cube minus t squared minus t. Let's open the brackets. It becomes 12t cube plus 4t squared minus 2t minus 3t squared. This becomes 3 minus 1, 2. Because of that minus 2t plus 1 minus 3t cube minus t squared minus t. So it becomes 9t cube. Then for t square, we have 1, 3t square. Okay, this will become plus and plus, right? So this becomes 1, 1 plus 1, 2. So it's plus 2t square. Then we have minus 3t because we have 1 minus 4 and then we have plus 1. This is your volume. What is the question? Question is also find the rate of change of volume. So now rate of change of volume. Now the rate of change of volume is going to be dv by dt. And that is equals to, just do the differentiation. Differentiation is 27t square plus 4t minus 3. We have to find out rate of change of volume at t is equals to 1 second. So we substitute t is equals to 1 here. Therefore, dv by dt at t equals to 1 is 27 plus 4 minus 3. So that becomes 28. Okay. That is your answer of the second part. There were two parts of this question. First has this answer, the second has this answer. Okay. It was easy only, and because this question was totally from the first concept of the vector analysis. So even if you have started it and you have done the first topic, this question was totally attempted. All right. Let's come to the next question. Question number 5th, D part. For 10 marks, this was from statics. A solid hemisphere, the topic was stable and unstable equilibrium. A solid hemisphere rests in equilibrium on a solid sphere of equal radius. Determine the stability of the equilibrium in two situations. Number 1, when the curved surface area, and number 2, when the flat surface of the hemisphere rests on the sphere. Before actually coming to the solution, let me also talk about one more thing. In the class, I say that statics and dynamics, you follow Krishna series, right? If you have done that, this was actually the first question of the Krishna series. So you can also figure out the level of this question. Usually the level increases when the number of questions increases. After 5th or 6th question, the level increases. But this was the very first question of the PDF that I have uploaded in the class. This was the first question. So it was a very easy question. What was required? See, there were few things already you need to know for this question. Number 1, how do we get stable or unstable equilibrium? 1 by h is greater than 1 by r plus 1 by r. If that is the situation, we know that then we know that equilibrium is stable. equilibrium is stable. Otherwise, for less than equals to sign, it's unstable. Unstable. So we just have to see that whether 1 by h is greater or less than or equals to this quantity, then I can say the equilibrium is stable or not. Okay. What is this h? What is this small r, capital R? Let's talk about that through the question. We have a solid hemisphere on a solid sphere. So there are two ways in which I can place a hemisphere on the sphere. This is a sphere and this is the hemisphere. You see, yes. What is given to us? It is given in the first part that when the curved surface of the hemisphere rests on the sphere. So this is the picture for the first part. What is the h? H is the distance of the point of contact of the two bodies. If this is, let's say, A point, this is A point, then the distance of this A from center of gravity of the object which is on the top. This is not a hollow hemisphere. This is a solid hemisphere. The difference between them is the center of gravity is different in solid and in hollow hemisphere. In solid hemisphere, if I take center of gravity at some point G right here. So this G is, if I take the center of this hemisphere as O, then beta, for the first part, this OG, or let us take that to be O dash. Let us take that to be O dash. So O dash G is equals to 3R by 8 if let R, because we have the equal radius, it is given. So let R be equal radius. Let R be equal radius of sphere and hemisphere. So we can start the question. If it would have been a hollow sphere, then center of gravity is just in the middle. If this area is if the radius is r, then it will be at r by 2 distance from the center. So in that case, this O dash G would have been r by 2. That is the only thing you need to take care in this question, that center of gravity, where is it present? What is H? Beta, H is AG. H over here is AG. So AG is equals to, obviously the total is R and O dash G is 3R by 8. So it is R minus 3R by 8, which is 5R by 8. And this will be taken as H. Say. So what would be 1 by H? 1 by H would be 8 by 5. And 1 by R plus 1 by R. Because here both the radius is R. Achha, now what is this R and capital R represent? This is not actually the radius, this is radius of curvature. But because we have the curvatures as the part of hemisphere and sphere, that is actually the part of a circle. So radius of curvature will be exact radius of the sphere and the hemisphere. Both have same radius, so this is equals to 2 by r. This is 10 by 5r. So you can compare this and this. Clearly, right? Clearly, 8 by 5r is less than 10 by 5r, which implies 1 by h is less than 1 by r plus 1 by r. And when it is less, then we say it's a stable equilibrium. So here, therefore, equilibrium is stable. Next part, second. Now it says when the flat surface of the hemisphere rests on the sphere. So how will be the picture? Picture will be just invert that hemisphere on the top. For the second part, same diagram. This hemisphere would be inverted. Like this. Note here that G is still the center of gravity of the hemisphere. It is still at a distance, if this is O dash, and this is O, the center of sphere. Still O dash G is the same. But this time O dash G is exactly your H, because H is the distance from the point of contact of two surfaces to the center of gravity of the solid at the top. So this time H is O dash G, which we know is 3r by 8. So 1 by H is 8 by 3r. And what is 1 by r plus 1 by r here? Same, 2 by r. So if I have to compare, let's multiply by 3, it becomes 6 by 3r. So again, clearly 8 by 3r is greater than 6 by 3r. 8 by 3r is the value of 1 by h. And this is value of 1 by r plus 1 by r. So therefore, equilibrium. Yeah, I'm sorry, I think I have written, yeah, this is unstable. Yes, this is unstable. For less, it is unstable. This is unstable. And for greater, equilibrium is stable. This is second part. And this is first. Easy. A direct question from stable and unstable equilibrium. Next, the last part of the first question in section B was this, but it had 2 parts, 5 marks for each, and it was easy. It may look very different in terms of this big expression, but if you remember formula, just by directly applying the formula, you can very easily get this expression. So this was again from a vector analysis. Let's start. Let C be a plane curve. Curve is given by r vector t is f of t I cap plus g of t j cap. Where f and g have second order derivative, show that the curvature at a point is given by this. What is the value of torsion at any point of this curve? All right. Formula that we are going to apply for curvature is what? See, curvature we have to so you just need to remember the formula of curvature, kappa. What is it in terms of r? In terms of r, and as you can see, this is in terms of t. So the formula is r dot cross r double dot divided by r dot q. Let's solve it. This is equation 1. We'll calculate numerator and denominator, and then we'll substitute in equation 1 to get the required expression. So what is r dot? R dot is first derivative plus g dash t j cap. Second derivative would be f double derivative plus g double derivative. We can write these derivatives because it is given that g and f have the second order derivative. So there is no question on the existence of the derivatives here. So what is r dot t or r dot cross r double dot? Cross product. Cross product is I cap, j cap, k cap, f dash t, g dash t, 0, f double derivative, g double derivative, and 0. So this is equals to, for I cap, obviously, this is 0 minus j cap, 0 plus k cap. For k cap, your derivative, this coefficient of k cap would be f dash t g double derivative t minus g dash t f double derivative of t. So what is magnitude? Because in the numerator, you want magnitude of this. So what is the magnitude? Magnitude is modulus of, because we don't have the coefficient of I cap and j cap. So we just have this. It will be, look at this. If I take this, if I take this to be C, then it is C K cap, right? So how will you find magnitude of this? It will be square root of C square, correct? Because coefficient of I cap and J cap are 0. So don't write it C, because C square square root, it would be modulus of C, not just C. So this will be modulus of f dash t g double derivative t minus g dash t f double derivative of t modulus. Your numerator is this. What's your denominator? Denominator is r dot q. Okay, r dot, first we'll find magnitude. So what is the magnitude of this r dot? Now, this is second. Now, r dot magnitude is square root of coefficient of I cap whole square plus coefficient of j cap whole square. It implies what is? It's cube f dash t whole square plus g dash t whole square raised to the power 1 by 2 was already there, and now it's 3. So 3 by 2. Using 2 and 3 in equation 1. Using 2 and 3 in equation 1. Kappa is, this is numerator, this is denominator. So f dash t g double derivative t minus g dash t f double derivative t modulus divided by f dash t whole square plus g dash t square raised to the power 3 by 2, which is your required expression. There is this next part of the question also. What is it? Yeah, so this is done. This is exactly the expression that we are getting. Next is, what is the value of torsion? So what is the value of torsion in terms of this R? Now, torsion is scalar triple product of R dot, R double dot, and R triple dot divided by R dot cross product with R double dot magnitude whole square. All right. So this here in the denominator, I can find from here because this is R dot cross R double dot magnitude. I just have to do square in the denominator. So this I can substitute from equation 2. Let's work on numerator now. Numerator is now R dot R double dot R triple dot can be written as R dot cross R double dot dot triple R triple dot. I have written it in this manner because I have already done this part. This part of the calculation, we have done it right here. This is R dot cross R double dot. It is this. So let's write it down. This is f dash t g double derivative t minus g dash t f double derivative t k cap dot product with what will be triple product, 3 times differentiation. This is f triple derivative p of I cap plus f g So this is f triple derivative t I cap plus g triple derivative t j cap, right? Because this is easy, see? Because first derivative, we did first derivative here. In the second, we did the second derivative. Now in the third derivative, this is third derivative. But you see the dot product. Dot product is going to be 0 because here I don't have a component of I cap and j cap, and this side we don't have the component of k cap. So it would be 0. Now numerator is 0. That means what? That means therefore tau is 0 for any point on curve. All right. That was your first part. Now we have second part. This is the second part. Show that the principal normal at 2 consecutive points of a curve do not intersect unless torsion is 0. This was also a more theoretical kind of question, but we can try it. There are only the formulas that you need to know. So let's see how to do this question. First of all, it says you have to show the principal normal at 2 consecutive points of the curve. What does that mean, 2 consecutive points? That means if this is a curve, this is the curve, let's say, and let's say that's the origin. So from O, this is the first point, P, and this is second point, some Q. If this has the position vector R vector, and this has position vector, so this is P R vector, and this has position vector r vector plus delta. Just a very small change. Two consecutive means just a very small change. So r plus delta r. These are two consecutive points of the curve. And then what will be PQ vector? PQ vector will be del of r vector, right? Principal normal do not intersect. And if it intersect, the torsion will be 0. So let's make two principal normal at these points. So principal normals will be perpendicular, and let me make in such a way that they intersect. So this is, let's say, the principal normal at Q point. And let's say this is principal normal at Q point. Okay, so this would be, if this is n vector, so I can take this to be n vector plus del of n vector. N is principal normal. Whatever you define in the figure, you have to write theoretically also. So first you will mention the 2 points. Let P with r vector as the position vector and Q with r vector plus del r vector as position vector be consecutive points on curve. Then let's talk about these unit principal normals. So unit principal normal means I'm taking only the n cap here. So let this n cap and n cap plus del n cap be the unit principal normal at P and Q. At P and Q respectively. One thing to observe here, and that was the only idea behind this question, only one part. If these two intersect, definitely they are coplanar. This we have done in analytic geometry also. If two lines are intersecting, that means definitely they are coplanar. Two lines are coplanar. But one additional part was, if they are intersecting with a del r, this vector uh, n cap plus d n cap or delta n cap and n cap. These three vectors will definitely be coplanar if they intersect. That was the only idea behind the question. So if principal normal intersect, then the vector, dr vector, then n vector and n vector plus dn vector. That is, so these three vectors are coplanar. And how can I write this? They are coplanar. Change it to delta. Yes. How to write mathematically? Mathematically, what can be equation wise? How can I write that these three vectors are coplanar? But when three vectors are coplanar, then obviously the volume that will be enclosed by these three vectors will be 0. And volume is calculated by scalar triple product. So scalar triple product of these three vectors are 0. It implies scalar triple product of del r vector, n vector, and n vector plus del n vector is going to be 0. Now, all the properties of this scalar triple product while solving, you can keep in mind that everything works exactly like finding the determinants and cross and determinants. So how this works? If you consider this as the determinant, so you know that if it is a plus b, you can separate this part. You can write it as del r vector n vector n vector plus del r vector n vector and del n vector. That is equals to 0. Just keep in mind, I'm using only the properties of determinants. Okay. So this is 0. This is 0 because if you write it in terms of del r vector dot n vector cross n vector. So obviously this is going to be 0 plus here I can do one thing. I can write it in as, see, I'm writing it as dr by ds dot ds. This is n and this also dn by ds dot ds. And now I can take common ds and ds from the first and the last term. So this is going to be ds square outside. This is dr vector, n vector and dn. That delta actually changes into differentiation. There should not be any confusion here. If you are confused with this, then you can start with dr from the very beginning. It represents a small change only. Okay. Now, this obviously cannot be 0, ds square, but what is, sorry, this is going to be dn by dr by ds and dn ds. Achha. What is this expression equals to? This is beta nothing but tangent. Remember, this was tangent, the formula. So this is ds square and this is tangent. This is n. And what is this? By Seret-Frenet formula. What will this come out to be? dn by ds. This is nothing but the binormal, right? And it had a formula. So tangent as it is, unit normal as it is, and this is binormal. So the formula was minus kappa. So I'm not using anything new here. All the formulas and all the concepts that we have done in the class, that has been used here. That is equals to 0. This is by Seret-Frenet formula. The name itself is in the syllabus, if you see. So now again, separate that. This is ds square t vector and then n vector, then minus kappa t vector plus t vector n vector tau b vector equals to 0. But again, look at this part. Here I can take that minus kappa common, right? So if I take minus kappa common, it will be ds whole square. ds whole square minus kappa common and will have scalar triple product of t vector, n vector and t vector. And when we have two same vectors in the scalar triple product, so this is going to be equals to 0. Plus here tau common. So t vector, n vector and b vector. So this is binormal and this is the derivative. No? This is derivative of n, not binormal. By mistake, I said that. Binormal vector is this, right? So this is equals to 0. And you see, if the first term is 0, now I'm left with, okay, that is 0. Tau of t vector, n vector and b vector. What are these? These are unit normals. No? These are unit vectors. tangent vector, normal vector, binormal vector, all of them are tangent vector here because this is d r by ds. This is t vector, unit vector along the tangent. So they are unit vector. And what is the scalar triple product represent? Volume. So what is the volume of a parallelepiped having all the length and breadth and height as 1, 1, 1? Volume will be 1. So tau is 0. And hence we get that result. The result is, therefore, the principal normal of the curve do not intersect unless torsion is 0. So when they intersect, that will be definitely only when tau is 0. Okay, hence the result. Which finish your mandatory section. Now let's start with 6A. And I know you're looking forward to this question. This question was from static and it was from virtual work. It was clearly written using the principle of virtual work. So it was, if you have gone through the syllabus, if you have done only the basic questions, not invested so much of time in the static dynamics, then also at least you were able to figure out that this question was from virtual work section, right? We know that all we need to find the equation of the virtual work. But before that, there is a lot of things to discuss. Let's discuss it. Let's see what is given in this question. A regular tetrahedron, that means all sides are equal, formed by 6 light rods. Light rod means no weight. So let me make a rough figure first. This is a tetrahedron, let's say. Let's say this is your regular tetrahedron with all the each of length L. Okay. So given is length of each rod is equals to L. That is if I name O, A, B, C. So that is OA is equals to OB is equals to OC is equals to AB is equals to BC is equals to CA. Is equals to L. Okay, that is given. What's next? L rests on the, it rests on the horizontal, smooth horizontal plane. That means there will be something like this. We have a horizontal plane in the bottom. A ring of weight W and R radius is supported by the slant slides. Now, this was a tricky part, but you see, it's very easy to interpret how that ring would be. The weight of the ring has to be considered because it is given. Weight of the rod need not to be considered because it's given light rods. So how that ring is supported by the slant height? Look at the slant height. What are the slant heights? OA, OB, and OC. These are the 3 slides, okay? So you imagine that you have a regular tetrahedron in front of you and you have a circular ring, okay? And you try to keep it through these slant slides like this, right? You try to cover it from the top. You try to cover it. So this is how it will look like, right? So let me make it right here. This is the circular ring. All right. And then it has a weight. So weight will be concentrated here in the middle and it will be W. Radius is R. So this is R. Okay. Is supported by the slant height. Using the principle of virtual work, find the stress in any of the horizontal slides. Okay. So let me make a bigger version of this diagram. Here I have to show so many more things as well. So let me zoom it. So now O, B, C, A. From here I drop the weight, which is W, or let me this is weight W. And if I take this point as P, let me take this point as P and this point as Q. So PQ is R. Radius is R. It is made of rods here. So we have done this in class. For string, we have tension. For rod, we have thrust. So the stress they are saying in any of the horizontal sides is nothing but thrust we are talking about. So thrust work in the opposite direction, right, toward the vertices. So I'm not going to show it in every rod, but it will be there. Like here also you have T thrust like this. Here also you have thrust like this. Here also it is toward the end of the rods, right? Because I have to find that thrust or the stress in the bottom, right? Because it's given that we have to find the stress in any of the horizontal sides, means the bottom, in either AB, BC, or AC. Here. So those will also be considered. I'm not drawing it here, okay, because it will be very complex. The diagram would be in that case. So it is there. I'm not drawing the thrust part. Other than that, how will you find out that equation of the virtual work that we require? Here you have to note one point. Tetrahedron is given to be regular. Since tetrahedron is regular, therefore, if we draw a perpendicular from O on plane ABC, now this was important to note, at some G point, let's say. So let's say this is the G point. Perpendicular from O to the plane ABC at G, then OG must passes through center P of circle. Beta, this is a more, general result in 3 dimension, but in 2 dimension also you can see. If I take a circle and if I have an equilateral triangle inside it, if I have an equilateral triangle inside a circle, then if you drop a perpendicular from any of the vertex of the triangle, that will definitely pass through the center of the circle. So just from that result, you can extend it in the 3 dimension. So that means this line right here from O, when I drop a perpendicular, if I drop a perpendicular, yeah, from O to G, if OG is the perpendicular, right, then definitely it passes through that P point. Okay, and from P also the vertically downward is the weight, so the direction is exactly same. The line of action of W is same as that perpendicular line that you have drawn. Now let OG makes an angle theta with each rod OA, OB, and OC. Again, it is only possible because it's a regular tetrahedron. And last thing, let T be the stress that we have to find. Stress in any of the horizontal sides AC, AB, or BC. Now you can try to write equation of virtual work. Let's try to understand how that would work. Okay. Note that how that weight is acting. Weight is acting vertically downward. So I can imagine first to find out the equation of virtual work, we imagine a virtual displacement, right? So where is the displacement? Where does that displacement occur? Beta, the circle, that ring is imposing a force in the vertically downward direction. So all the three slant height will tend to move downward at exactly the point of contact. So there are 3 points of contact here. This Q point, this R point, and let's say the third, here is some S point. So from all those 3 points, the distances from that plane ABC will reduce. I repeat, see this virtual displacement, I will take that the distance, I'm talking this perpendicular distance. Right? Every point has the perpendicular distance to that plane. All the distances will be reduced. Why? Because the W is applying in the vertical downward direction. And because all those are equal, because all these are equal, can I say that R, let's say this is R dash, S dash, and Q dash. All of them will be reduced and all of them are just equal to PG. All right, this is the theta that we have assumed. This is theta. Yeah. So we have talked about that W weight. How that W weight is affecting all those 3 slant height. It will reduce the height to the from the plane ABC. So minus W, because the distance is decreasing, minus W, W is the weight, W is the force into displacement. So change in PG. All right. And minus. Now, what's happening in the sides which are on the horizontal plane? Here, thrust is applied. Here, thrust is applied in the opposite direction like this. Okay. And for the rod, we know that it is a negative. Work done is a negative. That's a general article that we did. In tension, it is positive. That means in string, it is positive. In thrust, it's negative. So it's negative of, there are 3 rods in the on that horizontal plane. So it's 3P. And what is the change? Obviously, this AC is increasing. Right, so change is in AC. Why I have multiplied with 3? Because all the sides are also equal in length, and I am assuming that only T is the stress in all of them. So that's why it's just multiplied by 3. 3 del of AC equals to 0. That is your equation of virtual work. Now you have to find out PG and AC in terms of that known variables, like theta first of all, that we have assumed, and L is the known part here. So in terms of that, we have to calculate. L is known, W is known, R is known, in terms of all those things. Okay. Let's talk about PG first. So in PG, can we apply a, okay, this is perpendicular. So what if I join this A to G? Beta, this will be perpendicular, definitely. This will be perpendicular. This is an equilateral triangle. I have drawn a perpendicular. It will be definitely passing through that foot of the perpendicular that I have drawn from O. Again, rule from your regular tetrahedron. So, and it's a equilateral triangle. Now you can prove that it's a very easy concept like congruent triangle. This is an equilateral triangle. You have dropped a perpendicular. You can clearly prove that triangle 1 is congruent to triangle 2. So I'm talking about triangle A, EB and AEC here. AEB and AEC here. These two are congruent triangles. If these two are congruent triangles, it's an equilateral triangle. So this is also 30, this is also 30 degree, right? So let me make it, this is 30 degree here. And this right here is also 30 degree. Okay. And let's make all the perpendiculars, obviously that will pass through G only. So from B also I can draw it, from here also I can draw it. So from B, if I draw it, this is perpendicular. On the plane ABC, it's perpendicular. Okay. So from C also we can draw, but we don't need that. Look at this triangle. Triangle, if I take this point as D. Triangle ADG. Triangle ADG. In triangle ADG, what is cos 30? What is cos 30? You can find this is AD by AG. Cos 30 degree is AD by AG. Also in an equilateral triangle, when you drop a perpendicular, it automatically lands on the midpoint of the opposite side. So this D is automatically the midpoint. So if it is the midpoint, AC is L, AD is L by 2, right? AD is L by 2. But do we need that? If I have, let's see, this is L by 2. Let's find out AD from here. What will be AD? AD will be AG times cos 30 degree, right? Cos 30 degree. And how can we find this AG now? See, what is the idea behind finding all this? I'm trying to find AC here, right? But AC, I know that it is double of AD, right? So that's what we are trying to find out, AD here. But now since I have AD, I don't have AD in terms of the known variables. I'm allowed to have R, L and theta that will take out common. D theta will be taken common. We'll see that in the equation of virtual world. So I want these three variables in my expression. So now let's focus on AG. AG is in the triangle OGA. Can you see this triangle? This triangle right here. So in this triangle, can you see that how AG will be given? this AG can be written as, now in triangle OGA, GA, you have you can just apply sine theta. Sine theta is perpendicular upon base, perpendicular is AG, perpendicular upon hypotenuse, and hypotenuse is OA. OA is L. So now you have AG in terms of variables that we wanted. Now you substitute it here. So AD will become L sine theta, and if I substitute here, this is going to be, yeah, root 3 by 2. This is root 3 by 2. And what is AC? AC is 2 times AD. So let me mark this as 1. In 1, I need the value of AC. I need value of PG. So, and since AC is 2 times AD, therefore AC is L root 3 sine theta. This is the value that you need in your equation 1 of AC. And now let's focus on PG. What is PG? PG is easy to find. This length right here, this is PG. Sorry, from P. From this. This is PG. So I can find OP in triangle OPQ. I can find OG in triangle OGA, and then I'll subtract to get PG. So in triangle OPQ, now in triangle OPQ, this is, I have to involve OP, which is base, and then OQ, not OQ, PQ, which is perpendicular. So tan theta, let's find out. Tan theta is going to be equals to R divided by OP. From here you get OP as R cot theta. Okay. And in triangle OGA, in triangle OGA, I have to find out OG, and I can use OA because that I know that is L. So that becomes cos theta. Let's find cos theta here. So cos theta is OG divided by L. So what is OG? L cos theta. Now you have these both of these values. Now you can find, therefore, what is PG, which is OG minus OP, which is L cos theta minus R cot theta. And this is the next value that you want in your equation of virtual work. Therefore, equation 1 becomes, or you can write, using values from equation 2 and 3 in equation 1, we get minus W del L cos theta minus R cot theta minus 3T del of AC, which is L root 3 sine theta, is equals to 0. So what does it become? Let's do this total differentiation here. This is minus W L cos theta minus sine theta minus R minus cosecant square theta del theta That's what I was talking about. Del theta will be common actually, and that will go to 0 in the right hand side. Minus 3t, this is root 3l, and cos theta, again del theta. So del theta can be taken common, 0, and it becomes WL sine theta minus WR cosecant square theta minus 3 root 3L cos theta t is equals to 0. So let's find out t from here. T is W L sine theta minus R cosecant square theta divided by 3 root 3L cos theta. So it becomes T is equals to W by 3 root 3 tan theta minus R by L minus R by L. It becomes 1 by sine. So cosecant, let's take as it is cosecant square theta and then secant theta. This is a t. But as you can see, theta I cannot use here. Right? I cannot finish my answer here because theta is unknown. So to find out the theta, let's go back to where we found this AC, equation number 2. Can you see here that AC is actually L? AC is actually the complete length L. So from equation number 2, L is root 3L sine theta. So what is sine theta? Sine theta is 1 by root 3. Here you can find all the other values. Let me take that as 4. And so sine theta, what do we want here? We want tan theta, cosecant theta, and secant theta. So find out the values. It becomes cosecant theta is root 3. Secant theta is 1 upon square root of 1 minus sine square. So 1 by 3. So it will come out to be square root of 3 by 2. And what else? Tan theta. Tan theta is 1 by root 3. Sine theta divided by cos theta is root 2 by root 3. So it is 1 by root 2. Using all this, using values in 5, using values from 5 in equation 4, we get P is equals to W divided by 3 root 3 tan theta. Tan theta is 1 by root 2 minus R by L. Cosecant square theta becomes 3, and then we have secant theta. Secant theta is root 3 by root 2. Right? So I can take that common. W by 3 root 6, 1 minus R by L 3 root 3. Beta, that is your answer. This is the stress in any of the horizontal sides. All right. That was your 6A question. Next, 6B for 15 marks. This was from dynamics. Right? In that also, it's from that rectilinear motion, simple harmonic motion. A particle executes simple harmonic motion such that, so simple harmonic motion, let me take the center of the motion at some O point here, such that two of its position velocities are u and v. Okay. So let's take, this is the position A, where distance is u, and this distance is, such that in two of its position, oh, sorry, u and v are the velocities. Okay, I'm sorry, this is velocity. So velocities are given to be u here and v here. And the two corresponding acceleration at these 2 points are, this is F1 and F2. For what value of K? The distance between the two positions. The distance between this is AB. To do that, let's find out, let's take the distance from the center to this A as x1. And let's take the center distance from here as x2. This is x2. For what value of K, the distance between the two positions is K times V square minus U square. This is the first part of the question. So let's try to do that first. First of all, this is simple harmonic motion. What is equation of SHM with center as origin? So let equation of SHM with center as origin be d square x by dt square is equals to minus mu x. This is the first equation. After that, because for what value of A is the situation? Also, what is velocity? Velocity is given in terms of amplitude. Show that the amplitude of the motion is this. So let me take that amplitude to be A this right now. Also, dx by dt whole square is equals to mu times A square minus x square, where this A is amplitude. All right. We have two situations given, one at A position, other at B position. At A position, at position A, at position A, if I use these two equations from equation 1 and 2, so let's substitute the value. This is acceleration. What is acceleration at point A? F1. So F1 is equals to, beta, this time the distance, because I'm calculating from the center, so distance will be negative. So it would be minus mu of minus x1. So that will be mu of x1 and F2 is equals to, because if you remember this equation that we obtain the initial position of the particle right here. So it actually goes in toward A. But right now, we find the distance from the extreme point, not from the center. But here, because I'm doing that in the opposite direction, so that's why this distance would be negative. F2 is equals to mu times x2. Oh, okay, this is not at position A. Just a second. And if I use this is distance. Velocity. What is velocity at A point? Velocity is u. So let's substitute. So that means u is equals to, and u is equals to mu times A square minus x1 square. Okay. I can say this is 3 and this has 4. What happens at position B if I use this? So from equation 1 and 2, acceleration is mu times x2 and their velocity is v. So v square is equals to mu of a square minus x2 square. Do remember, we have to find distance between the two positions. We have to find AB. So it's obvious we have to find x2 minus x1 here. So to do that, what we can try, see. I can add 3 and 5 and subtract 6 and 4 to get that expression of x2 and x1 here. So from 3 and 5, what is f1 plus f2? That is mu common and x1 plus x2. And from 4 and 6. From 4 and 6, what is v square minus u square? Mu common, a square minus x2 square minus a square plus x1 square. Cancels. This is mu times x1 minus x2, x1 plus x2. You can find value of x1 plus x2 from here, right? So it is equals to mu times x1 minus x2 times f1 plus f2 divided by mu. This is from equation 7. So it implies x2 minus x1 was our target. x2 minus x1 is going to be minus u square minus v square. I have to adjust the minus here. Minus 1 upon f1 plus f2 times v square minus u square. You can take that to be k times v square minus u square, where so the question was, what should be the value of k for which the distance between them is k times v square minus u square. So the value of k is minus 1 upon f1 plus f2. There is a next part of the question as well where they are asking about the amplitude. So how to find amplitude? x1 minus x2. Now we have to keep a here. So what we can do, okay, what if I eliminate x1 from here? Because you see, x1 and x2 are the distances, are the variables that I have taken by myself. I cannot have in the expression. So as you can see, the x1 and x2 are nowhere present. I can end my expression either in u, v, f1 and f2. So if I want to eliminate this x1 from here, what I can do, I can find out x1 from here and substitute using 3 in 4. Using 3 in 4, we get u square is equals to mu a square minus, it was x1 square. So it is f1 square divided by mu square. So it is u square is equals to 1 mu will be there. A square mu square minus f1 square divided by this was mu. This was mu. So mu times u square is equals to a square u square minus f1 square. You can consider that because mu is also something we cannot end my my expression with mu. So if you observe, this is a quadratic we are getting in mu. Mu square minus, right, plus minus u square mu plus minus f1 square is equals to 0. This equation, equation number 8, I have obtained by using 3 in 4. Similarly, because they are very much alike, if I use 5th in 6th, then I get exactly the same expression. Obviously, f1 is f2 here, x1 is x2 here, u becomes v here. All the other things are same. So similarly, using 5 in 6, we get 6. We get a square mu square plus, this will be minus v square mu plus minus f2 square equals to 0. You have to find out, just find out mu from here by cross multiplication. Using or by cross multiplication, in equation 8 and 9, we get mu square divided by u square f2 square minus v square f1 square is equals to mu divided by minus f1 square a square plus f2 square a square. All right. So, and this is the last fraction, 1 upon minus v square a square plus u square a square. Find out mu square by equating first and the last fraction. From here, what is mu square? Mu square is u square f2 square minus v square f1 square divided by minus v square a square plus u square a square. B square. U square minus v square. And if I equate second and third, from second and third fraction, we get mu is equals to minus f1 square a square, or you can take a square common, plus f2 square a square divided by, I can take again a square common here, and it's u square minus v square a square. This will cancel. Now, by equating this is mu square and this is mu. So the square of this is equals to this fraction. Therefore, u square f2 square minus v square f1 square divided by u square minus v square a square is equals to, let's do the square of this. This is f2 square minus f1 square whole square divided by u square minus v square whole square. So what is a square? Or let me write one more time. This is u square f2 square minus v square f1 square divided by u square minus v square a square is equals to f2 square minus f1 square whole square divided by u square minus v square whole square. So this whole square cancelled with this expression, and what we get, a square. A square is u square minus v square times u square f2 square minus v square f1 square divided by f2 square minus f1 square whole square. So capital A becomes u square minus v square, u square f2 square minus v square f1 square whole to the power 1 by 2, and denominator, that square will be gone. It's f2 square minus f1 square. This is your expression. You can check here, 1 by f2 square minus f1 square, and this power half. It's exactly what we are getting. This was for question number 6B part. Next, question number 6, C part, first part. Here we have the C part is further divided into two parts. Both were very easy, 10 marks each. Find the second solution of the differential equation when one of the solution is given. When one of the solution is given, to find the second solution is quite easy. We just need to remember all those formulas, all those comparison we have to do with the equation. This is a second degree equation. So, given differential equation is xy double dash plus x minus 1 y dash minus y is equals to 0. That's the first. Ux is one of the solution, is given to be minus e raised to the power minus x as one solution. Now, comparing equation 1 with px y double dash plus qx y dash plus rx y. Y is equals to 0. We have px is equals to x, qx is equals to x minus 1, and rx is equals to minus 1. Now, second solution is simple, given by a formula. If you do remember that formula, you can very easily do this question. If then second solution is V times the first solution. That means the second solution is UV. Where, what is V? Where V of x is integration of e raised to the power integration of minus qx by px dx divided by ux whole square dx. That is the formula. Just apply, solve it. So let's solve this part first. Firstly, integration of qx by px dx is equals to integration of qx is x minus 1, px is x dx. So it's integration of 1 minus 1 by x dx. So integration of 1, x minus log x. then v of x is given by integration e raised to the power x minus log x divided by ux whole square. So ux is the given solution minus e raised to power minus x whole square dx. So what this will turn into? This will be e raised to power x dot e raised to the power minus log x divided by e raised to the power minus 2x dx. So this becomes e raised to the power. What is this? This is e raised to the power. Yeah, I missed a minus sign, right? There was a minus. This is a minus sign also. So it is supposed to be minus. So it is supposed to be minus x here and plus log x here. Yeah, now it's good. So that e raised to power log x becomes just x. That is x times e raised to power. What is this? This is 2 minus 1, x. You just apply that Eilert rule here. Right? What is this? Therefore, integration of this. It implies Vx is going to be x as it is, integration of e raised to power x is e raised to power x minus 1 e raised to power x. So V of x is coming out to be x minus 1 times e raised to the power x. But this is Vx, not the second solution. So second solution. So second solution was uv, u times v, which is u is minus e raised to power minus x times x minus 1 e raised to power x. This gets cancelled and it comes out to be 1 minus x. That is your second solution. Okay. Find the second solution. That's your second solution. That's the answer. There was a second part of this question also. Question number 6C, second part, again for 10 marks. Find the general solution of the differential equation, this by the method of variation of parameter. Variation of parameter is something that you should never leave in the ODE. That's very important topic. Let's find out. X square, this is just is equals to x cube sine x. As you can see, the homogeneous part of this ordinary differential equation is nothing but Cauchy-Euler equation. So you know what needs to be substituted for finding the CF, complementary function. So consider auxiliary equation to be x square y double dash minus 2xy dash plus 2y equals to 0. Now put x is equals to e raised to the power z. Right? It implies dx by dz is equals to e raised to the power z. Okay. So I can take that to be d1x is equals to e raised to the power z. So if I convert that into the differentiation with respect to z, so we know that this, let it be 1, let it be 2. So with this substitution, equation 2 becomes simply d1 minus 1 minus 2 times d1 plus 2 times y is equals to Yes, is equals to 0. So what is this? D1 square minus 3D1 plus 2 is equals to 0. So D1 is coming out to be 1 and 2 from here. Therefore, CF is given by C1 e raised to the power z plus C2 e raised to the power 2z, which is equals to C1 e raised to power z is x and e raised to power 2z would be x square. Now, for calculating particular integral, we take the help of variation of perimeter. That's where variation of perimeter comes into the picture. So for PI, we will use variation of perimeter by which what is a particular integral? That is u times fx plus v times gx, where first of all u and v are your linearly independent solutions that you're getting, x and x square. So where u is equals to x, v is equals to x square, f of x is equals to minus v r by w dx, gx is equals to u r by w dx. And what is w? Achha, we haven't compared also, so I think that needs to be done over here only. You compare in the beginning because you need that PQR. It's a y double dash minus 2x y dash by x square. So it becomes 2 by x plus 2 by x square y is equals to x cube. So it becomes x sin x. The comparison is done with the differential equation where the coefficient of y's double dash is 1. That's why I'm taking that common, or I'm dividing by x square. So it becomes x sin x. Let me take this as comparing equation 1 and comparing equation 1 with y double dash plus py dash plus qy is equals to r. We have p as minus 2 by x, q as 2 by x square, and r as x sin x. X sin x. Okay, so you have PQR. There is one missing part, which is W. What is W? And lastly, W is the Wronskian of U and V. So it's x square, and their derivatives 1 and 2x. Determinant, it's 2x square minus x square, so it's x square. Okay, so this is your particular integral where U and V are known. You have to find f and g. All the variables, all the things that you require to find out f and g are written here. Now f of x. Now f of x is minus integration of v. What is v? X square. What is r? X. So it's x sin x divided by w. W is x square. So w is x square dx. You have to do the integration of this x sin x. So it's integration of x sin x dx. Integrate, minus common, x as it is. Integration of this is minus cos x minus 1 plus sin x. So it becomes x cos x minus sin x. This is your fx, and g of x is equals to integration of ur. U is x, r is again x sin x, divided by r is divided by w is x square. So this x square cancels with these two, and I'm left with integration of sin x, which is just cos x. Therefore, PI, particular integral, is, what is u? U is x. So x times fx, which is this. So x squared cos x minus x sin x plus x squared times gx, that is cos x. As you can see, this becomes, yeah, this is not cancelled. This is 2x squared. All right. So this is 2x squared cos x minus x sin x. It was actually minus cos x, right? So it is minus cos x, which will give me minus x squared. So this bit gets cancelled, and I'll be left with minus x sin x. Therefore, y comes out to be CF plus PI. This was C1x plus C2x squared, C1x plus C2x squared minus x sin x. That's your answer. Let's come to the next question. 7th A part. Okay. It was for 15 marks, again from ordinary differential equation. But let me tell you one, let's have some discussion for this question. In ordinary differential equation, usually when we do the syllabus, even in the class, we target more and more questions so that we can cover more kind of a question, so that I can tackle with any kind of question in the exam, right? We don't focus on theorems, we don't focus on results, but still I have listed some statements of the theorem in class, including the uniqueness theorem. What I want to say is, even see, this question right here was asking only the statement. So we know how to write the statement and what is the statement of the uniqueness theorem. But even if they would have asked the proof, it doesn't mean now you'll start doing the proof of all those theorems. Some questions are meant to be not done in the question paper. If this question would have been asking about the proof, then obviously you'll leave this question. You'll save your time, you'll move ahead. Yes, this was actually a tricky question. Even after stating the uniqueness part, this part was tricky. We'll discuss that. So let's start. So first, I'll write the statement. State uniqueness theorem for the existence of unique solution of the initial value problem. This is called existence and uniqueness theorem, right? For the initial value problem given in this, in the rectangular region R, and R rectangle is given as this. So first, let's just state the theorem. So, uniqueness theorem, uniqueness and existence. Uniqueness and existence theorem. Existence theorem. We have a lengthy statement. So just be with me. Let there is a function be a continuous function. A continuous function in a domain D of xy plane. And we take a capital K be a constant such that f of xy modulus is less than equals to K in D. So please observe here, I am already starting with a function in two variable, which is a continuous function, and it is a bounded function also, because it is bounded in the domain D. In the domain D, it is bounded also, it is continuous also. Now, and the main part of this was, and f of xy satisfy Lipschitz condition. What is that condition? In Y. That is f of x comma y1 minus f of x comma y2 should be less than equals to some m times y1 minus y2, where m is independent of x, y, and x, y1 and y2. And please note that we also have a formula for finding that capital M. I'll discuss about it in the second part of the question, where we actually have to talk about this application. The application of this is in the second part. So M has a formula. So M is independent of this. Now, we take a rectangle in this domain where everything is true. See, in this, so inside the domain, I am taking a rectangle. So in this rectangle, my function will be continuous also, my function will be constant also, and my function will also satisfy Lipschitz condition. Right? So let rectangle R defined by x minus x naught less than equals to A. So obviously, this is also obvious that if I'm taking a rectangle centered at x naught comma y1, let's say this is the domain, right? So I am taking maybe a rectangle around this x naught comma y naught. I'm taking the complete rectangle to be inside the domain. So it's obvious that x naught comma y naught is also inside the domain, right? So let rectangle R defined by this and y minus y naught less than equals to B lies in D, where capital K is less than B minus A. The constant has to be less than B minus A. Then for x belonging to this domain, x minus x naught less than A, the differential equation, here I'm referring to the initial value problem. The differential equation dy by dx is equals to f of x comma y, where y of x naught was equals to y naught, has unique solution, y is equals to f of x. All right. This was the statement. So yes, it was a lengthy one, but at least statement you should know. You won't do proof even if they'll ask proof. Right? Maybe in the solution of the PYQs, I can write it, but you should not do proof of all the theorems now in ODE, in ordinary differential equation. Leave those questions if they are asking some proof. Now, moving ahead, there was a next part of the question, and let me just, give a summary of this theorem to you. We started in a domain. We started taking a domain, and in that domain, fxy was continuous. This is not, part of the solution. I'm just giving you a summary here. Look at this. This is f of x comma y was continuous in rectangle that we have taken, and it was bounded. And last, very important, Lipschitz condition was satisfied. If these three things happen, then I say that in this rectangle, this differential equation, initial value problem, has unique solution. There are so many other things also, like, for example, this k is less than b minus a and all those things. But roughly, this was the summary, right? Now the application. Question says, test the existence and uniqueness. So now you have to apply that theorem to the initial value problem this. So in simple language, you see that whether all these conditions are satisfied. If it does, then your equation will have unique solution. Simple. Okay, what is fxy here? Fxy is this. dy by dx is equals to f of xy. So this is f of xy, 2 root y. But they are not giving you any domain. They are giving you, they are saying in a suitable rectangle R. But whatever rectangle R you choose, that will definitely contain this 1, 0 point. Because they are giving you, over here, I told you that at least that rectangle will have x naught comma y naught. Right? So at least my rectangle will have 1, 0. So let's make a rectangle around 1, 0. Right? So here, f of x comma y is 2 root y, and x naught is equals to 1, y naught is equals to 0. So take R to be, now look at this, 1, 0, around 1, 0. So if I take a rectangle around, this is 1, 0, and I take the rectangle to be something like this, then you see there is a problem here. There is a problem. The problem is I cannot have this part, because in this region, y is negative. And I have root y here. So I will take a rectangle, not around 1, 0, but I will take a rectangle in which 1, 0 is present, because that was my target. 1, 0 has to be in the domain, right? So I will take the rectangle. I'll take a rectangle in which 1, 0 is also present and y is not negative. So I can actually reduce the area of this rectangle. And just a second. I can take the rectangle to be is the x-axis, and I can reduce the area because I'm not allowed to have the region below x-axis. So we can reduce it like this. 1 comma 0 is also included, and we don't have and we don't have the negative region of y as well. Okay. So we can take this length to be some a, 2a, this to be 2a, and I can take this region to be 2b. So take r to be x minus 1 is less than equals to a. And this side we can just take b, right? Not 2b, just b. And y should be between 0 to b. Yes. Because it cannot go in the negative part. For some, that doesn't matter, for some a comma b belongs to R positive. That is the suitable rectangle. Okay. Now, first 2 points are it should be continuous and it should be bounded. So obviously in this region it is continuous also and it is bounded. Why? Since root y is continuous, therefore f of x comma y, which is 2 root y, is also continuous on R. R is the rectangle. Then bounded also, y is less than equals to b. It implies root y is less than equals to root b. It implies 2 times root y is less than equals to 2b. It implies f of x comma y modulus is less than equals to 2b. B is already greater than 0, so I need not to put modulus here for all x comma y in the R. So in your rectangle, it is continuous, it is bounded. Now let's just the last point. If it is if it satisfies the last condition, which is Lipschitz condition, then this will have unique solution, right? But you see that condition has that m. Let's try to find that m. How do we find? Now we have capital M as supremum of all those xy belongs to R of del by del y of f of xy. This is how we find m. If this m exists, then I get that m that is required in this condition, and we get all the 3 points. We can say that it has a unique solution. So let's find out this. This is supremum of x comma y belongs to R. What is derivative? Partial derivative you can do with respect to y. This will give me 1 by root y. 1 by root y. But you need to have 1 comma 0 in your rectangle. That is the best we can do, right? This is a rectangle we have taken. 0 will definitely be there. So there will be definitely a path going to the 0. In simple language, I can say that this is the path on the x-axis that is going toward that 0, toward y is equals to 0. And if you follow that path, this 1 by root y will go to infinity. Infinity. This is only because that x comma 0 or that 1 comma 0, it is because 1 comma 0 is belonging to that R. That's why there is definitely a path toward that 1 comma 0. And if I move toward that path, this 1 by root y will go to the infinity because y is tending to 0. Therefore, that last condition which we were relied on is not true. This condition is not satisfied. And if this condition is not satisfied, then what? Then it does not has a continuous, it does not has a unique solution. The initial value problem does not have any unique solution. So you can write, therefore, Therefore, by existence and uniqueness theorem, is an uniqueness theorem, given differential equation, do not, it does not have unique solution. Okay, so we have applied. This is the second part of the question. First was state the theorem. We have done that. Test the existence and uniqueness. We have done that as well. If more than one solution exists, then find all the solution. That was the last part. So let's try to solve it. Initially, well, you actually try to solve it. You'll realize that how I'm getting multiple solutions, more than one solution, because it does not have a unique solution. That means I can have more than one solution. So initially, when you'll solve it, it's very easy to solve. So consider given differential equation as 1 by 2 root y dy is equals to dx. Just separating the variables. It's root y plus constant is equals to x. So root y is x minus c. Just look at this step. I'll come back to this step, right? Now, this is y is equals to x minus c whole square. How to find that c? Because a condition is given. Now, y of 1 is 0. It implies 0 is equals to 1 minus c whole square. It implies c is equals to 1. Therefore, y is equals to x minus 1 whole square is the solution. It looks like we have a unique solution. Then why uniqueness theorem was not satisfied? Again, come to this step. This step actually will tell you that there is a condition on the solution that we are getting. The root of y exists as x minus c. That means definitely this has to be positive. If this has to be positive, that means x has to be greater than 1. So yes, if I even do not consider it while solving the solution, this is the solution. But if I do consider it, it actually gives rise to more than one solution. Let me give you an example. Why this is a solution, by the way? This is the solution because if I find out dy by dx, it will definitely be 2 of root y. You can try. Right. Dy by dx. Yeah. And when you substitute x is equals to 1 here, then your y value will be 0. That's why it is the solution, right? Let me give you one more solution. But look at this. Y is equals to x minus 2 whole square, x greater than equals to 2, and 0 when x is less than 2 is also a solution. You can try that. You can try differentiating it. It will give you 2 root y, dy by dx 2 root y. And if you substitute y is equals to 1. Now, how will you substitute y is equals to 1? X is equals to 1. 1 is less than 2. So obviously the answer is 0. So it is satisfying that satisfying that condition which is given. Y of 0 is 1. Y of 1 is 0. And the differentiation is also 2 root y. You can try with this question. It's a perfectly differentiable function. And it's not just for this. In general, I can write y of x is x minus c whole square, where x is greater than or equals to c, and 0 when x is less than c is solution of differential equation. And this is collection of all the solution. That's what the question was asking. If it has more than one solution, find all of them. This is all of them. You can take C to be anything. Correct. C is any real number. Right. So this was also Good question. Next, we move toward this question. So what does this question says? It says a heavy particle hanging vertically from a fixed point by a light inextensible string of length L starts to move with the initial velocity u in a circle so as to make a complete revolution in a vertical plane. Show that the sum of tension at any ends of any diameter is constant. So first you read the question and then you reread it. You read it once again. But this time, the next time that when you are reading it, you divide your question into some parts and try to write the mathematical expression or try to write the diagram. This way you can understand the question very well. For example, let's again start reading it. There is a heavy particle hanging vertically from a fixed point, let's say O, it is hanging vertically by a light extensible string. So this is weight W, right? And the length is L of the string. So I'm taking that to be OA. OA is the string and after that there is a W force vertically downward. It starts to move with the initial velocity. Let's say the initial velocity is U here in a circle. So as to make a complete revolution. Okay, so this is the starting. So what we have assumed here, first of all, let O be a fixed point at which one end of the string OA is attached. At A, there is a body of, I'm taking it to be mass M, and that is freely. Note that L can be my expression. L can be my in the final expression. That's it. Yeah, these are the only two things given. Not this M and anything else that I'll take throughout. This W, nothing. Only L and U, because the variables that are given in the question, you can end your final expression only using those expressions, only using those variables, not anything else. So at A, a body of mass M is freely hanging. Now, body at A is projected horizontally with velocity u. So this is the initial phase. Now, I'll assume that after some time, B is the position. After time t, B is the position of this particle at A right now. So if B is position of particle, let's say this is O and this is O point. So initially it was at this point. It was vertically downward. This is O point, A point, and initially your particle was at A point, right? Now, after time t, let's take it is at some B point. This is the B point. So what we can do now, weight is still vertically downward. This is still W, right? First of all, let's figure it out how many forces will be acting at that B point. If B is position of the particle at time t, then two forces act on it. Number one, tension capital T of the string. That will be right here. This is T. And let's take this is theta. So second is weight mg vertically downward. These are the only two forces. Now, at B point, observe that what will be my tangential and normal acceleration. These two things you should know before doing this question. You should know what is tangential and normal acceleration expression. Normal acceleration is given by so tangential one is given by d square s by dt square. Beta, s is the distance from A to B. Basically, the arc AB is S. So it is, because it is positive, so it is in the direction of S increasing. As you can see here, yeah, this is the direction of S increasing. Okay, so this is the direction of tangential acceleration. You no need to write it. Actually, I've just shown you for making it clear. So this is in the direction of S increasing. And it is V square by L. It is normal vector drawn at B. This is a normal acceleration drawn at B inwards. So in this particular direction, we have the normal acceleration. Okay. Sure. Moving ahead, how this is useful? This will help us to find Newton's second law of motion, where force is equals to mass into acceleration. F is equals to ma. These equations, these expressions will be helpful there. So according to Newton's second law of motion, minus, or let's say m d square s by dt square. This is m into a, mass into acceleration, is equals to force. Which force is applying in this direction? Note that in this opposite direction, I have in this direction. What is this? If this is the tangent direct, this is a tangent at B. So this angle is also theta. Can you see? No, not this exactly. The other one. The other one with this part. This will be theta, right? This is theta. So if this is theta, then this W, which is mg actually, can have two components. This is mg cos theta. This is mg cos theta, and this is mg sin theta. Right? So direction is in the force, but it is in the opposite direction. So it will be minus mg sin theta in the tangential direction, and in the normal direction. And so I can take that to be 1. And mass into acceleration is equals to, yeah. So now in this direction, we have t will be the positive one and mg sin theta will be the negative one. So t minus, this will be t minus mg cos theta. Because direction of the acceleration is given here, a normal vector drawn at the inwards. So that is going to be, t is in this direction. So t is in positive, but mg cos theta is in opposite direction. So minus mg cos theta. From these two equations, we'll use these two equations. But one more thing, we know arc AB. What is arc AB? Arc AB, if I take that to be S, then S is equals to L theta. Achha. Now, if I do double differentiation with respect to t both sides, so this becomes L d square theta by dt square. That's third. Now, if I use 3 in 1, using equation 3 in 1, m times L d square theta by dt square is equals to minus mg sin theta. M and M cancels. It becomes, now if multiply 2 d theta by dt both sides, we get look at this, this is 2 times L, or I can write that L right here, and 2 d theta by dt. If I multiply with this d squared, I have to multiply it both sides. So it's on this side, it becomes minus Lg sine theta d theta by dt. You can rearrange the terms like 2L d theta by dt. And this can be written as let's multiply L also. 2L. So this becomes L square. So 1L I'll keep here and 1L I'll keep here. L d theta by dt. Kindly note this step, how I have written is equals to minus, there would be 2 also, minus 2Lg sine theta d theta by dt. Kindly note that if you do this differentiation, then L will be, L is constant, will come outside and you will get this double differentiation, that L will be multiplied with this L, we have L square. Okay, so I just have rearranged some expressions here. So this becomes 2, if I take this portion to be V, then it becomes 2V d by dt of V is equals to minus 2Lg sine theta d theta by dt. You can integrate this with respect to v, and this side minus 2 lg integration of sine theta d theta. This is going to be v square is equals to 2 lg cos theta plus some a dash, where a dash is constant. It's constant of integration. It's constant, right? Now, to find this constant, let's consider the case when the particle was at a point. So at point A, we know that theta was 0, there was no angle, right? And then velocity was u, right? And so it implies that u square is equals to 2lg cos 0 plus a dash. So what is a dash? A dash is u square minus 2lg. Note that here L is equals to d theta. D theta by dt is actually v. Why? Because from here, if you differentiate this dl by d theta, ds by d theta, so it is going to be ds by dt. So it is going to be L d theta by dt. And what is ds by dt? ds by dt is velocity. So that is something that I have used. This is something that I have used here. That is v. And the initial velocity was given as u. That is what I have used here. So I get the value of a dash, substitute a dash value. So you get v square is equals to this becomes, if I take this as equation number, let's say 4. So I can substitute. So equation 4 becomes v square is equals to 2lg cos theta plus u square minus 2lg. It's 2lg. So v square minus u square is equals to 2lg cos theta minus 1. That is 5. Now from this equation, we haven't used this equation yet. From equation 2, if I use the value of this v square, basically using value of v square from equation 5 in equation 2, we get in equation 2 we have mv square divided by L. Okay, or what I can do, I can find t from here. So t equals to mv square by L plus mg cos theta. So substitute value of v square here. So it will be 2lg cos theta minus 2lg plus u square plus mg cos theta. So t is equals to m by L. If I multiply L here, so it becomes 2lg cos theta minus 2lg plus u square plus GL cos theta. So it becomes M by L U square minus 2LG plus 3LG cos theta. Now, take any diameter PQ of circle. This is the tension that you got. Now, the question was, prove that the sum of the tension at ends of any diameter is constant. So if I take any diameter now, let's take this as the diameter PQ. This is P, this is Q. Then take any diameter PQ of circle. In that case, if angle, because here you need theta also. So theta means the angle which OQ is making with OA. So if I assume this angle AOQ as alpha, then obviously, you see, if this I assume to be alpha, this part alpha. So this complete with OP, it will be 360, pi plus alpha. All right. So I'll write tension at P point and at Q point, which are the ends of diameter. So if angle AOQ is alpha and angle AOP is pi plus alpha, let T1 and T2 be tension in strings QO and PO respectively. So even we have different tensions, we have taken the angles, then using equation 6. Look at equation 6, rewrite it. T1 will be M by L, initial velocity U square minus 2LG plus 3LG cos of alpha. This is 7. And T2 will be equals to M by L U square minus 2LG plus 3LG cos of pi plus alpha. So it becomes M by L U square minus 2LG minus 3LG cos alpha. We have to find the sum. We have to prove sum is constant. Now, T1 plus T2 is equals to 2ML U square minus 2LG, which is constant because obviously mass is constant, length of the string is constant, initial velocity is constant because it's independent of alpha. Since it is independent of alpha. So we wanted to prove T1 plus T2 is equals to constant, and here we have proved it. Now, few things about this question. Number one, as you can see, it's a very lengthy question. So you can clearly avoid some basic calculations here. For example, here I have totally derived the expression of t. If you remember what was t in this vertical motion, which you should in a circular motion, what is that tension, what is v velocity, you must remember these expressions. So you can directly start from equation number 6. You can define your diagram first, like this is a point, this is u is the velocity and all those things. after defining, you can directly come to the expression and you can solve it. You do not need to derive everything that I have done in this question. I have taken it from the very beginning, but you can totally avoid that because you can see that it will not be covered in the provided space. Okay, so you can definitely miss out some points here. But obviously, after equation number 6, you can't skip anything. You have to derive expression of T1, T2, add them and show that it's a constant. All right. This was your question number 7, B part. Next comes question number 7, C part for 20 marks. One question from either from Stokes theorem, Gauss divergence theorem definitely comes. So you should never leave this topic. Green's theorem, Stokes theorem and divergence theorem. These three theorems, you should do it in your preparation. Don't leave them. You definitely have one question from this. Okay. So state Stokes theorem. So I have already taken a cutout of the Stokes theorem. Beta, this is Stokes theorem. Okay. This is the statement. You can write it down. Now, the basic statement says that the single integration or line integral can be changed into surface integral using Stokes theorem. And we have to apply it. It says, and verify it for the vector field F over the surface S, which is the upwardly oriented part of the cylinder, this. All right. So if I take, let's do it here. This is x-axis, y-axis and z-axis. Look at the cylinder. Cylinder is z is equals to 1 minus x square. So z is equals to 1 minus x square means y also, the range of y is also given. Y is equals to minus 2 and 2. So this would be, and it is in the vertically upward one, and x is from 0 to 1. Okay. But how you will make z is equals to 1 minus x square? Note that. First of all, write down f here. Just give me a second, please. Okay. So y is from minus 2, right here, minus 2 to 2. And this, okay. So x is from 0 to 1. It's this cylinder, right? That's how cylinder would be made. This is 1 and this is 0. X is from the diagram would have been something like this. Now, if you join it like this, that is the cylinder we are talking here. Correct? That is the cylinder from 0 to 1, y from -2 to 2, and z is equals to 1 minus x square. Now, f is given to be xy I cap plus yz j cap plus xz k cap. That is the f given. A vector field over the surface, which is okay. Now we have to verify. What is Stokes' theorem? By Stokes' theorem, by Stokes' theorem, line integral over the curve C of f dot dr is equals to double integration over a surface del cross f vector dot n cap ds. Right? Now, please note here that this curve over which the around this surface would be these four curves I'm mentioning here. So let me give them a direction. The direction that we take is in positive direction. As you can see over here, C is transferred in positive direction. What is the positive direction? You imagine yourself walking on that curve in the direction which you have given. So if it is positive direction, like this. So just imagine that this is you're walking on the curve with your head pointing in the direction outward from the surface, not inside, outward. So your left hand side should have your surface. This is the correct direction. It's the positive direction. So if I take this curve to be C1, this curve to be C2, C3 and C4. Okay, so this is my curve, which is now divided into four parts: C1, C2, C3 and C4. Now, left hand side, which is C f dot dr, can be written as C1 f dot dr plus C2 f dot dr plus C3 f dot dr plus C4 f dot dr. So let's find out first f dot dr. On the curve y1, you can see y is from -2 to 2, but x is 1. Okay, so in curve C1, let me change the direction. Let me take this as C1, C2, C3 and C. Or in fact, let's keep it like that. Along C1, what's happening? See, along C1, I can note that x1 is constant throughout. So x is 1 here. X is 1. What is y? If x is 1, that means dx is 0. Right? What is y? Y runs from -2 to 2. So if I take y is equals to t, let's say, if I take y is equals to t, then dy is equals to dt. And what is z here? On this curve, z is 0. It is on the xy plane. So z is equals to 0. It implies dz is equals to 0. according to the direction of C1 that I have taken, y runs from -2 to 2. So along C1, f dot dr, first of all, this converts into y is t and t runs from -2 to 2. Now what is f? F is here I can actually find f dot dr first. Let's write down here. F dot dr is equals to xy I cap plus yz j cap plus xz k cap dot dx I cap dx I cap plus dy j cap plus dz k cap. Let's multiply. This will become xy dx plus yz dy plus xz dz. So substitute the values. Beta, xy is t. And just see the values here. Xy is t, xy times dx. Dx is 0. Plus yz, which is 0. Again plus xz, again 0. So this completely comes out to be 0. Now for integration over C2 f dot dr. What is x? This is the curve z is equals to 1 by 1 minus x square. And y is equals to 2 here. If x is equals to t, then first of all, this implies dx is equals to dt. Then z is equals to 1 minus t square, which means dz is equals to minus 2t dt. And because y is equals to 2, so it implies dy is 0. Y is 2, so dy is 0. Now you substitute. It implies integration over C2 f dot dr. Now let's substitute all the values. So what is t? This time t is x. And what is x from here? This is x from 1 to 0. Look at the direction of the curve C2. It's from here to here. So it's 1 and here x is 0. So 1 to 0. One to 0. And what was the expression? Expression was xy. That means 2 times t xy dx plus yz dy plus yz dy plus xz dz plus xz and then dz. So this is going to be 1 to 0 to outside t dt plus or minus 2 1 to 0 t square minus t raised to power 4 dt. So this is going to be 2 or just t square 0 minus 1 minus 2. This becomes t cube by 3. So minus 1 by 3 minus t 5. So plus 1 by 5. Right? So this becomes minus 1 plus minus 2, 15 minus 2 minus 1 plus 4 by 15. So it becomes minus 11 by 15. Okay. For C1 was 0. For C2 it was minus, it is minus 1, minus 11 by 12, minus 11 by 15. Now for C3. For C3, this is the curve C3. Here, x is 0 because it is on, this line is on YZ plane. So x is 0. Z is 1, obviously. And y runs from 2 to minus 2. Y runs from 2 to minus 2. So x is 0 here, which implies dx is 0. I'll take y as t. It implies dy is dt. And y runs from, or t runs from t runs from 2 to minus 2. Then we have z is equals to 1, which implies dz is equals to 0. Therefore, integration f dot dr vector is equals to, again, xy dx. So this is from 2 to minus 2. Xy dx 0 plus yz dy. Yz and dy and plus yz. And the last is xz. So xz is again 0, right? We have yz. All right. So this is a odd function. T is a odd function. From 2 to minus t, this integration will be 0. For the last curve, for C4, f dot dr. Here, this is C4. So here we have x. I can take x as t, so that z is 1 minus t square. X as t, which comes dx is equals to dt. So that z is equals to 1 minus t square, which gives me dz is equals to minus 2t dt. And y is equals to minus 2, right? Which implies dy is equals to 0. So x is from 0 to 1 here. So as you can see, the direction of this curve is here. So here x is 0 and here x is 1. Right? This is 1. So x is from 0 to 1. So integration 0, this is C4 f dot dr is equals to x is from 0 to 1. Again, it is xy, so minus 2t. Xy, dx is dt, plus yz dy, because dy is 0, so it becomes 0. And last is xz dz. So xz and dz. dz was minus 2t dt. Solve it. This is going to be minus 2, 0 to 1 t dt plus or minus 2, 0 to 1 t square minus t raised to the power 4 dt. Okay. So it becomes minus t square by 2, 2 and 2 cancel. That t square, 1 minus 0, so it will just become 1 here. Then minus 2, this becomes t cube by 3 minus t raised to power 5 by 5 from t equals to 0 to t equals to 1. So minus, I can, it as 1 minus 2. It is, if you substitute 1, it's 1 by 3 minus 1 by 5. Solve it. That is equals to minus 1 minus 2. 5 minus 3, 2 by 15. So this becomes minus 15 minus 4, so it's minus 19 by 15. Therefore, integration over C f dot dr vector, which is equals to integration over C1 f dot dr vector plus over C2 f dot dr plus C3 f dot dr plus C4 f dot dr. That is equals to, first one was minus 11 by 15. For second, it was 0. For first, it was 0. For second, it was minus 11 by 15. That was 0, 0 minus 11 by 15 plus 0 and minus 19 by 15. So that is equals to minus 30 by 15. That is minus 2. That is your left hand side. Now we have to solve the right hand side also. Right hand side is double integration. This part we have to solve. To solve this, you need to know how to solve this surface integral. We have a simple formula for that. What is it? First of all, let's find integrand which requires this curl we have to find. We have to take the dot product with n cap. So let's see. Now moving forward, what is curl of f vector, which is del vector cross f. So it is I cap, j cap, k cap, del by del x, del by del y, and del by del z. And f was xy, yz, and xz. So this is equals to I cap differentiation with respect to y 0 minus differentiation with respect to z is y minus j cap z minus 0 plus k cap. This is 0 minus x. So it becomes minus y I cap minus z k cap minus x k cap. All right. Now, what is n cap? Which is del of beta phi. Phi is where? Phi is the surface. Phi is equivalent to z minus 1 plus x square. So that is del of z minus 1 plus x square. Differentiated with respect to x, I cap with respect to y, 0, j cap with respect to z, 1, k cap. So it is coming out, it is n vector right now. It's coming out to be 2x I cap plus k cap. So it implies n cap is, we divide by its denominator, 2x I cap plus k cap divided by its magnitude. Magnitude is going to be 1 plus 4x square. Next. So how to find that integrand part? Therefore, curl f vector dot n cap is equals to, just do the dot product. This is curl and this is n. As you can see, I have I cap component, I have k cap component, I don't have z component, so that will no longer be there. So it will be minus 2xy and minus x divided by, so this is divided by 1 plus 4x square. That is your integrand. But how do we solve that surface integral? Better to solve the surface integral, we need to take a projection. So S del cross F dot n cap ds is equals to projection, where this R is projection of S on xy plane. So if you are taking projection on xy plane, this formula converts into, this is your integrand. Integrand is minus, if I take common, 2xy plus x divided by square root of 1 plus 4x square dot dx dy divided by n cap dot k cap. K cap is the unit vector perpendicular to the xy plane. The projection where we take the unit vector perpendicular to that plane over here. So what is n cap dot k cap? See, this is n cap. Now, n cap dot k cap is equal to, see, I'm showing all these calculations, but if you think you do not need to write it, you can directly substitute in the expression, you do that. Because as you can see, it is already going very lengthy. So there were many things where you can leave, writing those calculations. For example, this C1 and C3 was clearly coming out to be 0. So just by writing these substitutions, you can write integration is 0. You don't need to show that this integration, putting the values, and no need to do that. Obviously, the calculations will need some space. Give them the space for the question. This part will occupy the space, but where you can totally avoid, just avoid writing solving this 0 integrations. That is clearly 0. This part, n dot k, is also something that you can directly write. But I'm showing you, that's why I'm writing. So this is 2x I cap plus k cap divided by square root of 1 plus 4x square dot k cap. And we have to find the magnitude. So that is equals to magnitude of, just multiply, take the dot product. If you take the dot product, it is 1 upon 1 plus root. So it will be 1 upon root 1 plus 4x square. Now you substitute here in this expression, therefore, surface integral del f dot n cap ds becomes, now substitute the values and you see what happens on the projection of x. If I take projection of this surface, which is bounded by these 4 curves, C1, C2, C3, C4. If you take the projection on XY, so you will get a rectangle. Can you see that rectangle? That rectangle would be here. You see, you are taking the projection. This is the projection. So if I take that projection right here, it will look like right? That will be the projection you'll be getting. Obviously, this is 1, right? X is from 0 to 1 and y is from -2 to 2. So you know the limits of this integration. Limits of this integration is -2 to 2 and 0 to 1. Okay, these are the limits. Okay, let's substitute the value. Okay. Also, if you substitute the value here, this becomes, see, minus outside, x also outside, it's 2y plus 1 divided by square root of 1 plus 4x square, or dx by dy, and that is coming out to be 1 by root 1 plus 4x square. So this gets cancelled, right? And I can do this integration. With respect to x, it's x square by 2, so minus 1 by 2 outside, -2 to 2, and x square, if I put the limit, it's just 1, so it's 2y plus 1 dy. So it's -1 by 2 y square plus y -2 to 2. This is anyways, means this is odd function. So again, the integration from -2 to 2 is 0. We only have to take care of this 1. Integration is y, substitute the limit. So it's -1 by 2. 2 minus -2. -2, 4. So -4 by 2 -2. Since this integration is equals to 2 and it is also equals to surface integral, hence verified. I have written everything clearly here, to show you each and every step. I have shown you every calculation, but most of the part you can just skip writing it here and you can do it in rough work and you write the final answer to save your space. So this was your question number 7, last part. Next, we have question number 8a for 15 marks. It was using Laplace transformation. That means it is from ordinary differential equation. It's from ordinary differential equation. If this theorem was not supposed to be here. Okay, no problem. I'll take care of that. See, actually, this was supposed to be in the next, for the next question right here. All right. Using Laplace transform, solve the initial value problem where this delta t minus 2 denote the Dirac delta function. All right. If you remember all the formulas of Laplace, which I say from the very beginning, please make a formula list and you read them daily. Just read them once daily, you'll be able to learn all the formulas. So let's start this question by applying Laplace both sides. So given equation is this. By applying Laplace, it will be Laplace of y double derivative plus 2ly derivative plus 5 times Laplace of y is equals to Laplace of delta t minus 2. Obviously, you need to know what is this delta Dirac function and how the Laplace work on it. So it was very simple actually. And you see, this is on the left hand side, it is s square. It's the formula Laplace of y minus s y of 0 minus y dash of 0 plus 2 times this would be s L of y minus y of 0 plus 5 L of y and that is equals to, let me right now keep this delta function as it is. Let me just simplify the left hand side first. So in the left hand side, you see y of 0 is 0 and y dash 0 is 0. So these three terms, 0, they all go to 0. So it is s square L of y plus 2s L of y plus 5 L of y is equals to Laplace of this Dirac delta function. Let's write the formula. So beta, here I can take L of y common and I get s square plus 2s plus 5, and this side it is nothing but e raised to the power minus 2s. Why? You write formula because Laplace of delta t minus a is equals to e raised to the power minus s times 2 only, not 2, minus sa only if a is greater than 0, or you can write where a is greater than 0. So here a that I am using is 2, so obviously it is greater than 0, so I can apply this formula. And now there was nothing in this question. You find out Laplace of y, that is equals to e raised to the power minus 2s divided by s square plus 2s plus 5, right? So first you take that e raised to power minus 2s aside and you take the Laplace inverse of the fraction that you get here, this one, Laplace inverse of this part. Now, this is 1. Now, what is Laplace inverse of 1 upon s square plus 2s plus 5? Where, let's complete the square. So it is plus 1 minus 1. So this is equals to Laplace inverse of 1 upon, it's s plus 1 whole square, 5 minus 1, 4. So it's plus 2 square. So it is what? It is, I have to multiply and divide by 2. So it's 1 by 2 e raised to, because s is actually replaced by s plus 1. So I have to multiply it by e raised to power minus t and sine it is of sine, right? Yeah, sine t, sine 2t. What is this used? Which theorem is used here? It's the second shifting theorem, if you remember. Okay, it's the second shifting theorem that I'm going to apply here. This is first shifting theorem. In the second shifting theorem, why I have calculated Laplace inverse of only this much part? Because, right, now from 1, y is equals to Laplace inverse of e raised to power minus 2s divided by s square plus 2s plus 5, right? Now, what is second shifting theorem? Using second shifting theorem, which says using second shifting theorem, which says Laplace of g of t is e raised to power minus as f of s. So if you are taking Laplace inverse of this part, so you should know g of t. What is g of t? Where where g of t is small f of t minus a when t is greater than a, and 0 when t is less than a, and where this small f of t is coming, and capital F is nothing but L of Laplace of f of t. So this is already your f of t. You have obtained it. You can directly write the answer. Just make the comparison. Just apply second shifting theorem here. So it is going to be, let me write it now. So it is equals to y of t is equals to 1 by 2. What was the function? 1 by 2 e raised to power t sine 2t. So t will be replaced by t minus 2 because t will be replaced by t minus a here. So it is going to be 1 by 2 e raised to power minus t minus 2 sine of 2t minus 2 where t is greater than 2 and 0 when t is less than 2. This is your answer. All right, let's move to the next question. Next question is 8th B for 15 marks using Gauss divergence theorem. As I said, Stokes theorem, Gauss divergence theorem, there is always at least one question. Here we had two questions. This is Gauss divergence theorem. This is the statement of Gauss divergence theorem. Stokes theorem tells you a relation between line integral and surface integral, and divergence theorem tells you a relation between surface integral and volume integral. So even if it was not asked, it would be an impression to write the statement. And that's why I say at least you should know statement of every theorem. So statement, write down the statement first, and then evaluate this over the region bounded by the cylinder and the plane z is equals to 1, z is equals to 5. All right, so let's start. First of all, how the diagram looks like. Cylinder is x square plus y square is equals to 16. So, and z is equals to 1. So, this is where z is equals to 1. And this is where z is equals to 5, let's say. So, this is the given cylinder. That's where z is equals to 1. That says z is equals to 5. And this is x square plus y square is equals to 16. We have to evaluate the surface integral, and if I use Gauss divergence theorem, I can convert into volume integral, correct? So I have to evaluate double integration of y square I cap plus x z cube j cap plus z minus 1 square k cap plus z minus 1 square k cap dot n. Dot n cap ds. This is what we have to calculate. All right. So we have to find divergence, because here, look at this. We have to find divergence of f. Let's find out. Now, divergence of f is, with respect to x, it's 0. With respect to y, 0. With respect to z, 2z minus 1. So, by Gauss divergence theorem, this surface integral y square I cap this becomes del of f vector dot dv. That is the conversion into volume integral, correct? So I have calculated divergence of v. I just have to multiply it with dv. But note that when I write it, means when I convert it into the volume integral, what does it becomes? It is y square I cap y square I cap plus xz cube j cap plus z minus 1 square k cap dot n cap ds is equals to volume integral over, now you have calculated this is 2z minus 1 dv. You can change this integration into cylindrical coordinates. In cylindrical coordinates, in cylindrical coordinates, x is r cos theta, y is r sin theta, and z remains z. So r is obviously 0 to 4 because 4 is the radius. This is 4 square. Z is from 1 to 5 and theta is from 0 to 2 pi. This is equals to 1 to 5 z. Theta is from 0 to 2 pi. And r is from 0 to 4. And here I have 2 times z minus 1. dv was actually dx, dy, dz. That is converted into r, dr, d theta, dz. So for 0 to 2 pi. If I integrate with respect to r first, it is r square by 2. R square means 16. In the limit, if I substitute the limit, so 16 by 2. 16 by 2 is 8. 8 times 2 is 16. Z minus 1 d theta dz. Now 16 you can take outside. 1 to 5 z minus 1 dz. And this is 1 d theta. 0 to 2 pi. So it becomes 16 z square by 2 minus z. Z is equals to 1 to 5 and theta is 2 pi. So this is equals to 32 pi 25/2 minus 5 minus 1/2 minus 1. 32 pi. 15/2 minus, so it's plus 1/2. It becomes 32 pi. 16/2, 8. So this is 256 pi. That is your answer. We don't have to verify this time the theorem. So it's not like I have to find out left hand side and right hand side separately. No, I have to use it to find the integration. So I can convert surface integral to volume integral using the theorem, and then I can calculate. This is your answer. Now comes the last part. Last question, 8C. A particle moves with a central acceleration mu being projected from a distance d at an angle 45 degree with the velocity equal to that in a circle of the same distance. Prove that the time it takes to reach the center of the force is this. What is central acceleration given here? Central acceleration is given to us, right? So note here, central acceleration is given as mu 3 by r cube plus d square by r raised to power 5. That is equals to p, let's say. So if capital V is the velocity in the circle, that's the circle, and we have central. We have to prove that the time it takes to reach the center of the force. Okay. So it is toward the center. That is it. Being projected from a distance d at an angle 45 degree. Okay. So if V is the velocity, let's say, if V is velocity in a circle at a distance, because distance is given at a distance d under the same acceleration. Under the same acceleration, then what? Then I can write P at r is equals to d. Okay. So then I can write V square by d is equals to, just substitute. Here I have to just substitute r as d. So mu times 3 by d cube plus d square by d raised to power 5. This is actually P where r is d. So V square by d is equals to mu. This gets cancelled. It's 3. So 3 plus 1, 4. 4 by d cube. So it implies V square. Take that. So V square is equals to 2 root mu divided by, because it gets cancelled, d square. So it's d. This is V. Yeah. Now you get the expression of V. What is differential equation of its path? That is needed, right? So what is differential equation of the path? That will be equals to, beta, this is h square u square plus, in every equation, differential equation you have to write and you have to solve this differential equation. Here we have p by u square. What is u? U is 1 by r. So it is mu by u square. In your expression, it is 3 by r cube. So 1 by r is u, right? So I can substitute. This is 3 u cube plus d square u raised to power 5. Why? Because u is 1 by r. U is 1 by r. That's what I have used in this relation. Next. This is equals to mu times 3u plus d square u raised to the power 3. So how to solve it? You just multiply first 2 du by d theta both sides. Multiply 2 du by d theta both sides. So we get, this is, I already have h square outside, so it becomes 2h square du by d theta u plus d square u square d theta square, and this side will get 2 mu 3u plus d square u cube, and we have du by d theta. All right. So h square as it is, this is 2, is it u or u square? Yeah, I'm sorry, that is in the differential equation, it's u, it's not u square. So it becomes 2u du by d theta, and this becomes 2 du by d theta times d square u by d theta square. That's the kind of form we want here. 2 mu 3u plus d square u cube du by d theta. I can write it 2u du by d theta plus, please observe, this is 2 times du by d theta and d by d theta of du by d theta. That is equals to 2 mu 3u plus d square u cube du by d theta. Now beta integrate. Now integrate. So you'll get h square 2 integration of u du plus 2 integration of du by d theta of d du by d theta is equals to 2 mu becomes integration of 3u plus d square u cube du. I have eliminated that d theta throughout. So it becomes h square u square plus du by d theta whole square. And what is this? What is this expression equals to? I hope you remember all the formulas at least. This is v square, right? And it is coming out to be 2 mu 3u square by 2 plus d square u raised to power 4 by 4 plus a constant of integration. That is one. To find that a constant of integration, we use the initial condition. It's given, but initially when r is equals to d, that is u is 1 by d, we have v calculated, v, it's right here, and phi is 45 degree. 45 degree is also given in the question, see? So velocity so I can write initially v is 2 root mu divided by d and phi is 45 degree. So it will give you, what does it mean? It means P is equals to R sine pi becomes D sine pi by 4. It becomes D by root 2. And P is, this is P. It implies this 1 by h square times u square plus du by d theta whole square. That will be equals to, do the reciprocal, root 2 by d and do the square. It's 2 by d square. It's coming out to be this, which implies now you can use this value in equation 1. So now from equation 1, look at this. The first is this v square. V square is what? This is v. So v square is 4 mu by d square. So it becomes from 1, 4 mu by d square is equals to, here we have h square. So here we have h square multiply by 2 by d square. So this 1 by p square will give you the expression of u square plus du by d theta whole square, which will be equals to 2 by d square. Now from equation 1, note that in equation 1, this v square, what is v? This is v. So v square means 4 mu by d square. So 4 mu by d square, that will be equals to, this is h square times this expression we have already calculated here. It's 2 by d square. So it's multiply 2 by d square, that is equals to here. Here we have mu, u is equals to 1 by d. So let's substitute. It's 2 mu 3 by 2 d square and plus d square by 4 plus d square by 4 and d raised to power 4. Cancel this 2 and this becomes 4. This becomes 2. So it is mu times 3 by d square plus 1 upon 2d square. Okay. So it becomes 6 minus 1. There's a plus a also. This plus a is also there, right? So that was 4 and it is cancelled, become 2. So how can we find, if I equate first and the second expression here, so what I'll get, d square cancelled, 2 and 4 cancels. So I'll get h square is equals to 2 mu. And if I equate first with the last fraction, then I can get the value of a. What will be a? A will be, or I can compare the second and third. Let's compare second and third. So what is a? A is equals to 2h square by d square minus 3 mu by d square minus mu by 2d square. So what is it equals to? This is 6 mu minus mu divided by 2d square. That's cancelled. Okay, sorry, this is 8. Yes, this is 8. So it doesn't get cancelled. 2 minus mu. So it's mu divided by 2d squared. Therefore, h square is 2 mu and a is mu by 2d square. Substitute this value of h square and a in the equation number 1 and proceed. Substitute this value. Substitute this value of h square and a in equation 1. We get so equation number 1 is this v square. Okay, so I'm going to substitute here. H square is 2 mu, so it becomes 2 mu u square plus du by d theta whole square, that is equals to mu times 3 u square plus d square u raised to power 4 by 2 plus a is mu by 2d square. Okay, so I can notice here the few things are getting cancelled. First of all, this mu and mu is gone. So we are left with 2u square plus 2 du by d theta whole square is equals to 3u square plus d square u raised to power 4 upon 2 so this becomes plus 1 upon 2d square. So 2 du by d theta whole square is equals to u square plus d square, because that 2 square will come this side. So 3u square minus 2u square will become u square, and the rest of the terms as it is 1 upon 2d square, and this we can take it to be 2. So taking now u as 1 by r, du by d theta becomes minus 1 by r square dr by d theta. So equation 2 becomes just substitute, it becomes 2 1 upon r raised to power 4 dr by d theta whole square is equals to 1 by r square. This is du by d theta square. One by r square plus d square by 2 r raised to the power 4 plus 1 by 2 d square. So this becomes d divided by r raised to power 8 dr by d theta square is equals to, take LCM, 2 r raised to power 4 d square. So it becomes 2 r square d square plus d raised to power 4 plus r raised to power 4. It is actually outside the bracket. This is square inside. This is 1 by r square, so it becomes 4, not 8, it becomes 4. All right. So that r raised to power 4 and r raised to power 4 cancel out. And we are left with 4d square dr by d theta square is equals to 2r square d square plus d raised to power 4 plus r raised to power 4. This is nothing but r square plus d square whole square. So what is dr by d theta? That will be in plus and minus, but we'll take only minus sign, minus r square plus d square divided by 2d. Why negative sign? Negative sign because when r decreases, because r is decreasing obviously when theta increases. When theta is increasing. So we have h is r square d theta by dt, which can be written as d theta by dr dot dr by dt. This we know the formula. Substitute the values. H square was coming out to be 2 mu. So h is coming out to be square root of 2 mu. That is equals to minus r. And what is this d theta by dr? If I take this as equation number 3 and I already have. So let's do one thing. Let me mark this as equation star. And this is double star, okay? So I'm using equation star here and I'm using equation 3 here. Minus r square, and what is d theta by dr? That is going to be 2d divided by r square plus d square dr by dt. I have substituted values from star and 3. So what is dt? Dt is minus 2d divided by root 2 of mu. This is r square divided by r square plus d square dr. And now we have to find out t, right? We have to find out time. So we have dt here, dr here. Just integrating from r is equals to d to r is equals to 0. Integrating this and time time taken. And instead of writing time taken, let's take and required time. And required time t1 from distance d to the center of force is given by, so this side will have just t1, this side will have minus 2d divided by square root of 2 mu integration r equals to d to 0 and r square divided by r square plus d square dr. You're almost there to the answer, just few more minutes. So this is minus 2, or you can write it. Minus 2d upon root 2 of mu. Okay, let's do the integration. You add d square and subtract d square. So first integration will be d to 0, 1 dr minus r is equals to d to 0 and d square divided by r square plus d square dr. So this will be minus d, right? And minus, this is d tan inverse of r by d, where r is from d to 0. So this becomes minus d, and it is 0 minus pi by 4. So it becomes minus d and plus d pi by 4. All right. So what is your T1? Don't forget the expression that we have here. So if I take d common from the bracket, it becomes minus 2d square divided by square root of 2 mu and minus 1 plus pi by 4. In order to adjust that 2, I can write the last expression as d square divided by root 2 mu 2 minus pi by 2. That is the required time and that is your final answer. So I hope it was useful for you. So main point is revision. If you remember all the formulas, all the equations, all the expressions, then you can apply it. That's it for this video. I hope that this was helpful. Thank you, everyone.